Pleasant morning to one and all. I'm Dr. Sumitra. I'm here to present you about the video to a text transcriptions using LSTM models. Converting a video to the text involves extracting the information from the visual content of the video and converting into a textual representations of a long-term memory network, and a type of a recurrent neural network can be used for this task. And these LSTMs are particularly useful for a sequential data like a video frame. Video to text conversions, also known as a video captions, is a technique that aims to bridge the gap by automatically generating a textual descriptions or the captions for or a video content that plays a crucial part in making a video content more accessible, searchable and understandable. What makes this LSTM suitable for video captions? A sequential handling, that is sequential data handling, and temporal relationship, memory cells, vanishing the gradient problem, gating mechanism. Sequential data handling is all about the LSTM designed for a sequential data which is suitable for the video frame, and the temporal relationship where it captures a temporal dependency crucially for a video understanding. And the memory cell LSTMs uses a memory cell for storing, retrieving the informations over a sequence. Vanishing the gradient problem dictates vanishing the gradient problem for effective training. Gating the mechanism, input for gates and output gates, controls the information flows. And we have a variable sequence method where this variable sequence method will handles your video and varying the length, providing a flexibility. Where we have a feature extractions too, which combines with a convolution layer for caption for a spatial feature extractions. The basic working of this video to text description is all about. First process is the data collections or the pre-processing. Remembering that the video is made for a several number of frames, the step involves extracting the frames from the video and converting them into a format suitable for input into an LSTM network. Additionally, the textual data for training and evaluation is prepared. We have a video features and a feature extractions, where the video framing are often transformed to a feature vector using techniques like a convolutional neural network. The convolutional neural network or distinguished from other neural network by superior performance with the image, speech or audio signal input. This feature captures the visual informations in a more abstract form, which is then held into an LSTM network. The sequence to the sequence model flows the encoder decoder architecture, where the input is a sequence of the video frame and the output is a sequence of the word. We estimate a conditional probability of an input sequence given in an input sequence of x1 to xn. The basic training of this LSTM is carried out by encoding and decoding. The encoding in the first several times of a top LSTM, the first receives a sequence of the frame and encodes them, while the second LSTM layer receives the hidden representations and concatenate it with the null padded input words which it then encodes. Once all the frames are encoded, then we send VOS, that is tagged, to the second LSTM, which prompts is to start decoding its current hidden representations into a sequence of words. And we have a decoding process, whereas the decoding is a model means maximize for a log livelihood for a predicted output sentence given with the hidden representations of a visual frame sequence, and the previous words will also be stated. This log likelihood is optimized over the entire training datasets using a stochastic gradient descent, and the loss is computed only when an LSTM is learning to decode. The loss which we have stated is all about is prohibited back in time, and the LSTM learns to generate an appropriate hidden states of the input sequence. And we have a score calculation. The second LSTM green layer produces a score for the word based on the vocabulary corpus, which is laid into a softmax function which converts us the raw score logics produced by the model into the probabilistic distributions over the vocabulary of possible words. Hence, for the decoding, during the decoding phase, the visual frame representation for the first LSTM layer is simply a vector of a 0 that acts as an padding input. As a result, we can able to use a end of the sentence tag to terminate each sentence. And the basic challenges on the LSTM, we can state that it is an ambiguity and the diversity. The problem of generating a description is open domain video, which is difficult or not just due to the diverse just set of objects or the sequence and the actions and their attributes, but also it is hard to determine the salient content, and the description describes the event appropriate in context. As a computational intensive, we can state that training and using an LSTM based models can be computationally intensive, particularly for a large video data sets. Training may be requires a significant computational resources and the time. The data dependency is where it is an LSTM relies heavily on a quality and the quantity of a training data. Without diverse and the representative data sets, the model performance may be limited. And the overfitting is all about the LSTM are prone to overfitting, especially if the data set is small or noisy. Overfit model perform well on the training data but generalize poorly to user and unseen data. Hence, I can conclude that the basic applications of LSTM model for the video to the text transcription represents the video to text conversions using LSTM is very powerful technologies with numerous applications, from improving an accessibility to enhancing a content retrieval and the summarization. The LSTM model, with their ability to capture the temporal dependency, plays a vital role in the process. As the field continues to evolve, it promises to make a video content more accessibility and comprehensively for a broader audiences. So the future resources could also be focused on improving the model's robustness to converse the basic background noises and visual descriptions in video. I hope you are clear with this concept. Thank you.